In this video, we're going to review exponential derivative rules. So one of our simplest exponential rules is that the derivative of e to the x is e to the x. Not too bad. Our other exponential rule would be if it had a different base besides e. So maybe it has 2 to the x. The derivative of 2 to the x is ln of 2 times 2 to the x. Not too bad still. Do ln of your base, and then your base to the original power, and then the derivative of e to the x is just e to the x, the original base to the original power. Of course, these can get more complicated if your exponent gets more complicated. So if you have e to the x squared minus 1, you would take the derivative of your power. So derivative of x squared is 2x, derivative of negative 1 is 0. So there's the derivative of the power, and you multiply that with e to the original power. Now, if the same thing happens with a different base, where your exponent gets more complicated, so say you have 7 to the x cubed plus 4, x. You have 7 to a power that's not just x. It's kind of like having 2 to the x, but you have more than just an x in your exponent. So just like with the e to the x squared minus 1, we took the derivative of the power first. We're going to do that same thing here. Derivative of x cubed is 3x squared. Derivative of 4x is 4. There's the derivative of the power, and then instead of doing 7 to the original power next, I want to remember to do ln of 7. Order doesn't matter for multiplication, but I do like to be consistent in my order. Derivative of the power, natural log of your base, base to the original power. We can do another example of these. Say you have the derivative of 5x plus e to the x to the 10th. Well, the derivative of 5x is just 5. And then you have e to a power that's not just a regular x. So we want to take the derivative of that power. So we're going to take the derivative of x to the 10th, which will be 10x to the 9 by bringing down that power and subtracting 1 from the new power. So derivative of the power, e to the original power. If we had that with a different base, say we had f of x is maybe e to the x plus 4 to the x to the 5th minus 2. Well, the derivative of e to the x is just e to the x. Derivative of 4 to the x to the 5th minus 2, there's more than just an x in the power, so I'm going to take the derivative of the power. Derivative of x to the 5th is 5x to the 4th. Derivative of negative 2 is 0 because it's a constant. So we have the derivative of the power. We need ln of our base, and our base to the original power. All right, so in general, we have 4 rules going on here. Derivative of e to the x is e to the x. Derivative of any other base, like 2 to the x, would be ln of 2 times 2 to the x. Ln of your base times your base to the original power. So if you have 10 to the x is ln of 10 times 10 to the x. If you had the derivative of 13 to the x, you'd do ln of 13 times 13 to the x. There's our first 2 rules. The next rule is if you have e to more than just x as the power. Take the derivative of the power times e to the original power. Derivative of the power times e to the original power. And then lastly, our 4th exponential rule is if you have a different base to a power that's more than x. So with this one, 7 to the x cubed plus 4x, you take the derivative of the power, ln of the base, base to the original power. For any base other than e, derivative of the power, ln of your base, base to the original power. So let's do one more that has all 4 of these exponential rules in it to wrap things up. Let's call it g of x is e to the x plus 14 to the x plus e to the x to the 3rd minus 4 plus 9 to the x squared. starting with e to the x, the simplest one. Derivative of e to the x is e to the x. Next one, we have a different base besides e, so the derivative is going to be ln of that base times that base to the original power. And now these last two have x in the exponent still, so it's going to be one of our exponential rules. But if the power is more than x, you start with the derivative of that power. So derivative of x cubed minus 4 is just 3x squared. Derivative of the power times e to the original power. Last one, we need to take the derivative of the power. Derivative of x squared is 2x. And since the base is not e, we're going to do ln of our base. Then we'll do base to the original power. There's all 4 of our rules at once.